This is JEE 2020 paper 1 of physics section 1. In this section there are 6 questions. Each question has 4 options, only one option is correct, and there is negative marking also. -1 marks is for negative marks and +3 for full correct. So let's start our video right after this short break. And if you are first time on my video, then please like, subscribe and don't forget to hit the bell icon button to get the video first.
Audio Jungle. Audio Jungle.
Question number 1. A football of radius capital R is kept on a hole of radius small r. Okay. A small r is less than capital R. Made on a plank kept horizontally. One end of the plank is now lifted so that it gets tilted, making an angle theta from the horizontal as shown in the figure. The maximum value of theta so that the football does not start rolling down the plank satisfies figure is schematic and not drawn to scale. Fine. Now, as you know, this plank is lifting over here. Let's solve. And football, the radius was capital R, and 2r is the radius, 2r is the diameter over here of this one hole. So small r is the radius. So what you have to do, you have to first of all, from the corners of the hole, means from these corners where the football is, means that is the also called, you can say, point of contact. Here, that is, this one is the point of contact over here. From this point of contact, what you have to draw? You have to draw the reaction force from here and here. Both the reaction force passes through centers. So better just you just draw from reaction force over here. And weight mg is also acting downwards. So from this same point which counters this reaction force. And here, if you draw the line perpendicular over here from this line joining of this plank, so that it will be also making an angle theta. As you say, this is theta, 90 minus theta. So finally, in this way, in this triangle, you can find the value with the help of this theta. You can find this theta, and you will get the relation between theta as using trigonometry. Sine theta is equal to altitude upon hypotenuse. So in this way, sine theta, either tan theta, cos theta, any of the theta you can find. So this is our strategy. Now let's start. So the solution, let's see the solution over here. So here, this is the plank of the normal, as what we have discussed previous, that you have to draw the normal reaction. This is the normal reaction, and this is the weight mg. If you extend this line, this is 90 degree. Here, this is theta. This is 90 minus theta, and vertically opposite 90 minus theta. This one is 90, so this will be also theta. So the normal tends to verge of rolling, and this verge of the rolling mass, let's see here, this one, the verge of rolling mass mg, this one theta, makes, so in this triangle you say sine theta equal to altitude upon hypotenuse small r by r. That is our option. This one, A option, is correct. A option is correct. Okay, fine. So let's see. Anyhow, come to the question number 2. Question number 2. That is, a light disc is made up of aluminium, means a non-magnetic material is kept over here, and this one, and is free to rotate about the axis as shown in the figure. A strong magnet is held vertically at a point above the disc away from the axis. On revolving the magnet about the axis of the disc will, means figure is schematic and not drawn to scale. So here the magnet is there. This is North Pole, this is South Pole, and you know this here. So what happened here, due to this motion movement of this magnet here, so the disc, this one disc is from of what is said here. The disc is made up of aluminium. Okay, a light disc made up of aluminium here. So, and a non-magnetic material. So due to this Lenz's law, here always here the magnetic pole will be arises such that, so it opposes the motion of the magnet itself. So due to that opposing, here the disk also rotates. So the rotation direction you have to account over here. As you know, the Lenz law, what is Lenz law? The disk also tries to move in the same direction, because in the backward part of the disk, flux reduces as magnet moves, and that is the change in the magnetic flux. So there will be the eddy current here, the eddy current production, which leads to the production of heat. So here, due to this Lenz law, we can say that the rotation will be also in the same direction, because when the magnet goes like this way, so the disk tries to oppose here the movement of the motion. If it goes clockwise, then it tries to move this, and so north pole, and here also north pole generates, and due to this the generation of this same pole here, the and the eddy current flows, and the aluminum disc also moves along the same direction of the movement of the this one magnet. So finally, what the option will be? The option is very clear. Rotate in the same direction as the direction of the magnet's movement, means B option is correct. Okay. And this is a top view. Here the magnet, B option is correct. Yes. Top view. And this is due to this eddy current generation. Here, this is Lenz law. The reason is the Lenz law and eddy current production, which leads the production of heat. Now, next question, question number 3. A small roller of diameter 20 centimeter has an axle of diameter 10 centimeter. See figure below on the left. It is on a horizontal floor, and a meter scale is positioned horizontally on its axle. Okay, with 1 inch of the scale on the top of the axle. See figure on the right. This one, axle is over here. Okay, fine. And here these are the options given over here. So how to tackle this? What do you have to see over here? In this, if you see over here, this part. So this part here, what is given in the question? In the question, it is given here. This is radius is 20 centimeter, and diameter is 20 centimeter. So diameter 20 centimeter has an axle, and diameter 10 centimeter. Small roller of diameter 20 centimeter has an axle of 10 centimeter. Okay, fine. So, what you have to do over here, that here you have to use this one, means omega, let omega be the angular velocity. Let the angular velocity be omega, and v be the velocity. Let's see here. V minus omega are equal to, here, as v is this velocity, and v and omega are this here. Omega r goes like this way, v. So v minus omega r here 0 on this. So v equal to omega r. Now substitute the value of here, the radius over here. So that we say omega equal to v by 20, and velocity of the point at A will be v plus omega r. So now substitute the value of omega over here, v by 20, and r, that is 10. So that is 3v by 2, and solving we get 1.5 volt. So the distance moved by the point of contact is 1.5 into 50 centimeter, that is finally 75 centimeter. So B option is correct. If you see over here, this one is B option. Yes, x equal to 0, and here x equal to 75. This option is correct. Let's go for question number 4. A circular coil of radius capital R and capital N turns has negligible resistance as shown in the figure. Okay, so for here, as shown in the schematic diagram, its two ends are connected to the two wires and is hanging off those wires with its plane being vertical. The wires are connected with the capacitor of charge capital Q. Here, this one is capacitor and charge capital Q through a switch. The coil is horizontal uniform magnetic field. Okay, here magnetic field is there. B naught is given parallel to the coil, which when the switch is closed, the capacitor gets discharged through the coil in very short time. By the time of the capacitor discharge fully, magnitude of the angular momentum gained by the coil. Okay, this coil you have to find angular momentum for this coil. Assume that the discharge time is so short that the coil has hardly rotated during this time. Okay, fine. Options are given. So if you see here that here, let's see, this is the magnetic field. B naught magnetic field is there. Due to this magnetic field, here there is a means coil is to be rotated over there, made torque produce. So you can find here after closing the switch within a fraction of second, entire charge flows through coil and produces impulsive torque here. Here it produces impulsive torque. So due to this impulsive torque, you can find its angular momentum as the formula of angular momentum, del L you can say angular momentum. The change in angular momentum is equal to integral of tau dt. So you have to integrate this tau, and tau you can find with the number of turns. Number of turns is given over here. Okay, n means number of turns is n on all the options. N is given here. Here means number of turns are, let's say, n. So means NBIA. What is the formula? Tau, that is tau is equal to NBIA sine theta, So tau, NBIA you can directly write here. So NBIA, and here that is dt. So tau, integrate this and del L, and the integral of this one means instead of I current, you can say this is charge, capacitor charge you can use here. So for area, that is pi r square. R is the radius, probably it's given here, r radius and n turns. Yes, so pi r square you can use over here. So the here the options will be according to this pi r in the integral of this one dt time up to this one. So I dt, integral of I dt, that will be q. Q will be the charge here. This is the total charge over with charge q through a switch. So NBI a dt. So A, for A you have to use pi r square, integral of I dt, that is q. So that the option will be B option. Yes, pi n q B naught r square. It's very easy. Yes, here integral of tau dt, that is del L, and B I A dt is equal to del L, and B I A for area you have to use pi r square, and integral of I dt, that is q, and here pi n q B naught pi r square del. This is the change in angular momentum. Question number 5. Let's see. A parallel beam of light strikes with a piece of transparent glass having cross section as shown in the figure. Okay, this one. And here the correct shape of emergent of wave front will be figure shown. Figures are schematic and not drawn to scale. In all the questions they are using this one. So here this is the concept of, this is all based on Huygens principle, Huygens wave theory. So theory of wavefront is there. So what is the theory of wavefront? Wave moves such that the direction of propagation is perpendicular to the wavefront. Wave moves such that the direction of the propagation is perpendicular to the wavefront. So this is, in this way we can see here, if you see the perpendicular means the light is coming over here. So here when this is a curved face, so light bends over here from these faces. From these faces lights bend towards here, and as this is a surface, and on these surfaces light disperse. From these surfaces, if you see here, light disperse. So just here the mirror image type of mirror image of this one, you will get this, because this is according to Huygens theory, that is wave moves such that the direction of propagation is perpendicular to the wavefront. So this is the only way here you will see this pattern, and this pattern. So the pattern is like this way. If you see, A option is correct. Yes, A option is correct. It's quite easy. Yes, this one is A option, and this is all Huygens theory. Let's say question number 6. An open-ended U-tube of uniform cross-section area contains density 10 to the power 3 kilogram per meter cube. Initially, the water level stands at 0.29 meter from the bottom in each arm. Yes, kerosene oil A water immiscible liquid of density 800 kilogram per meter cube is added to the left arm until the length is 0.1 meter as shown in the schematic figure below. Okay, the ratio of H1 by H2, the ratio H1 by H2 of the heights of the liquids in the two arms is, this one is H1 height and this one is H2 heights, another liquid. Okay, so how to tackle this? This is a question from fluid mechanics, and here it is a hydrostatics. So means pressure will be at same level, same horizontal level. The pressure will be same, means pressure at this one point. So let this point be A and this point be B on this base. You can assume this as A and this as B. So pressure at A and pressure at B on these, on the bottom, on this bottom points, let's say A, and this bottom point, let's say B. So pressure at A and pressure at B are equal. You can equate this pressure, and with the help of this you can find pressure. The formula P is equal to P naught plus rho GH, and here atmospheric pressure you have to consider, and rho GH2, and here also P is equal to P naught plus rho GH1 minus whatever there is 0.1, this pressure you have to consider this. So let's go ahead for solution. Yes, so let's see, this is A point and this B point. At A point you can find this as same horizontal level, pressure will be same. So at A point, what is the pressure is there? Pressure ATM pressure, that is P ATM, and here rho, that was the kerosene oil is over here, as in this question. Kerosene, the density is given. Yes, density is given over here. So rho GH, that is 0.1, and plus rho G, this one H1 minus 0.1. This one is liquid. So rho WG, density of this liquid, and density of the same liquid W over here, and rho GH2. So equate this pressure. Equating this pressure, you just substitute these values. ATM and ATM cancel, pressure ATM, and then substitute these values as per requisite. You will get the value of solving this equation 1, and here H1 and H2. Equation 1. Also, this is the initial level here. Initial level, both the arms, that is, you can solve this value and you will get this H1 and H2, that is the option here. After solving you will get 35, 33. So this is B option is correct. B option is correct, 35 by 33. Thank you. So we'll meet in the next video of section 2 of paper 1 as well. Paper 2 also we will solve later on. So in the paper 1 section 2 we will go ahead. Thank you very much for watching.